Hello and welcome back to TensorFlow. In this video, we are going to learn one of the most important milestone in probability and statistics, and also one of the biggest foundation behind artificial intelligence, machine learning, and deep learning algorithms, Bayes theorem. Bayes theorem is not just a formula, it is a way of thinking. It helps machine update their beliefs when new data arrives, which is exactly how modern AI systems work. In this video, you will clearly understand what Bayes' theorem is and how it is different from conditional probability, and most importantly, the core intuition behind it. So we will derive the Bayes' theorem step by step so you'll know where the formula comes from, not just how to use it. So let's get started and understand the theory part. So before getting into the definition, let me give you an example from which we will understand Bayes theorem, and we will also differentiate between conditional probability and Bayes theorem. So let's say there is a person P, and let me give you the description of this person. This person is introvert. He is an introvert, and he like reading books. He like books. Now, tell me that what is most probable, that this person is farmer or he is a librarian? What is most likely, that he is a farmer or he is a librarian given this description? So, conditional probability will say that it is most probably he is a librarian, because these traits usually we see in librarians, because librarians are mostly introverts and likes reading books. This trait is of librarian more than a farmer. But now let me give you some more information, some more additional information about this question. Let's say there is a village and there lives 100 people, and out of these 100 people, 95 are farmers and 5 are librarians. Now I say that I took out this person P from this village. Now tell me, what is the probability that given this description the person is a farmer, and what is the probability that given this description the person is librarian, and what is most probably that the person is a farmer or a librarian? So after getting this data in conditional probability, you can't do anything as such, because it is only dependent on this term. It is only seeing the description and making the decision. And this is the problem with conditional probability. It is not dependent on this data. But if we have additional information, if we have additional data, we have to utilize it. So here Bayes theorem comes in. What Bayes theorem did is, it took this data in the confidence and then recalculated the result. So if you will give the additional information to Bayes theorem, it will update the beliefs. But in conditional probability, it is fixed. It is only dependent on the description. It is only dependent on the condition which is given. Now, let me give you the intuition of this problem. So out of these 95 farmers, there is a most probable chance that 20 of them fit in the description. 20 of the farmer fits this description very accurately, because there is no such thing as very certain that this description is of librarian only, because normal people are also introvert and they like reading books, and a farmer is a normal human being. He could be introvert and he likes reading books. And all the librarians, it's not sure that all the librarians are introvert or all the librarians likes reading books. Let's say there are only 4 librarians that likes reading books and introvert, but one librarian is only doing that librarian thing for profession, for money. So this librarian do not fit in this description, but these 20 farmer fits in this description. So uh, now we have this new data that these 20 farmers fit in this description, and these 4 librarians fits in this description. Now given this data, what is most probable, that the given person, this person P, is a farmer or librarian? Because the population of farmer is far more than the population of librarian, it is most probably that the given person is a farmer. So the probability of farmer here, will be more than the probability of librarian. And this is how we update our beliefs when we get new data in Bayes theorem. So now let's jump into the formula. So the formula of Bayes theorem, because we are asking the same question, so this is the person given the description, so we can write it like in more in general form, like A given B. So the probability of A given B is probability is equal to the probability of B given A multiplied by probability of A upon probability of B. So this is the formula of Bayes theorem. Now let's compare it with the formula of conditional probability. So in previous video, I've explained conditional probability very clearly with an example and intuition. So if you want to watch, go and watch that video and then come to this explanation to get a more clear understanding. So conditional probability. Probability of A given B is equal to probability of A intersection B divided by probability of B. This is the formula of conditional probability. Now, if you look at this formula, this is only dependent on the condition that B. So it is only dependent on B. But Bayes theorem is taking everything in account. It is calculating the probability of B given A, probability of A, and probability of B. So this formula uh, take full data into the calculation and then calculate the probability. But this formula, this conditional probability formula, only take the condition. Like in this example, it is only seeing the description, not this data, which is very crucial, because if you took this person from this village, it is more likely to be a farmer, because the population of farmer is far more than the population of librarian. So conditional probability is not useful because it is not taking this data in account. But Bayes theorem is also taking this data in account and then calculating the probabilities. So it is also called reverse probability because we are asking reverse questions. So now let's derive this formula from this conditional probability formula. So this is the conditional probability of A given B. Now let's see the conditional probability of B given A. So conditional probability of B given A is probability of A intersection B divided by probability of A. So this is the formula of conditional probability. Now, if we will see this term is common in both the formulas. So we will equate this formula. So it will be equal to probability of A given B multiplied by probability of B will be equal to the probability of B given A multiplied by probability of A. So now we will equate this. So probability of A given B will be equal to probability of B given A, probability of B given A divided by probability of B and multiply by probability of A. And this is the formula of Bayes theorem. And this is the derivation of Bayes theorem. So let's conclude everything that we have learned. So uh, 20 out of 95 librarians, 20 out of 95 farmers are also quiet and introvert and like reading books. But 4 out of 5 librarians are introvert and like reading books. So yes, the probability of introvert and like reading books, this description fits more in librarian, but they also exist among farmers, because the population of farmer is more and the population of librarian is less. So this will affect the result of our probabilities. So Bayes theorem tells us, don't just look at the description, don't just look at the description that he is introvert and he like reading books. Also look at how common each group is. Because the group of farmer is 95 and the group of librarian is only 5. So when we combine both piece of information, we get the base rate and the evidence. So it is more likely that the person P is a farmer than a librarian. So the core idea of Bayes theorem is probability is not fixed. It can change and it update when new information arrives. So we have to update this probability, our beliefs, when the new data arrives, and new data is this. So there are some common terms in the formula, that prior and evidence. So prior is basically what we already know, that this person fits this description, and evidence is what we observe, and this is the evidence. So these are some common terminologies, but we don't have to get in the terminologies because we are using it for machine learning and deep learning algorithms. So we just have to know the core essence of Bayes theorem, and this is one of the most important theorems in probability, and it is widely used in artificial intelligence algorithms. So This is exactly how AI and machine learning models work. Spam filters, medical diagnosis systems, recommendation engines, they all start with the prior beliefs and update it when new data comes in. And that updating process is called Bayes theorem. So let's say spam detection. So we have some prior beliefs that this particular email is a spam, and then new data arrives that this email has some words like free, words like reward. So these words are more common in spam emails. So it will ultimately take that email as a spam. So this is how Bayes theorem works behind the scenes, and this is the formula of Bayes theorem, and we see that how to prove it. Now here is a website called Seeing Theory, and here you can understand Bayes theorem, and you can test it on different data, and you can also test it on sample data, and then you can draw a table and understand it more intuitively and visually. So let's say we want to test on this sample population. This is very famous example of a medical test, which is the original example used to explain Bayes theorem. So this is that example. Here you can see that example and calculate the probabilities, and if you'll sort, it will sort the diagnosed population. So here you can visualize Bayes theorem. Now, in next video, we will try to understand some more theorems, or we will use this Bayes theorem to make a machine learning algorithm.